AP Calculus AB Monday, April 17th. Got the 8.11 notes. Doing a little bit of volume with the washer method. Okay. A little bit of washer method. Okay.
You said I can watch YouTube.
Yeah, as long as it's like legit. If it's not legit, I'm having you put it away.
What?
Andrew, you watching YouTube?
What's your channel called?
Michael Rushka. Mike Rushka.
Mike or Michael?
I forget.
It's like your
Other
last
Mike.
name. Subscribe to you. I have post notifications.
Dude, you copied my name. Your mom saw my dad's last name was
I think Kristen, my dad's name Johnny Johnson. Mother Johnny. He's married too.
get that one music artist for the
Alright, so washer method. So this is a lot like the disk method. The difference here, so basically think of this as like a, you guys like see like, you ever go to Psalms? Everyone, you ever get the coffee cake at Psalms? Alright, so you know those like, okay. So like, you know what like a bunk cake is?
Yeah.
Okay, so what's going to happen, they're going to take this little area right here and rotate it around the horizontal axis so that it makes a little bump cake shape. Okay, we're going to rotate around so it makes a little bump cake shape. Okay, we got to find the volume of the cake. Okay, we got to find the volume of the cake. What's different about this from the problems we did last week? So last week we did problems where the shape was touching, right? So we tried to do, so if we try to find the volume of this surface of revolution, the bottom side, the entire bottom side of the area is touching the axis that we're revolving around, right? Okay, here it's not, so we gotta do a little something special. So what we got to do is it's just like the disk method. It's like combining the area stuff we did with the disk method. We subtract the top curve from the bottom curve. If our axis of revolution is horizontal, we do top minus bottom. So top squared minus bottom squared times pi. Okay, it's like two disk methods. Okay. If our axis of revolution is vertical, we do right minus left. Right squared minus left squared times pi. Integrated from top to bottom. Okay. Remember, if my axis of revolution is vertical, I have to integrate with respect to y. Right, because all my circles are stacked, like top to bottom. Instead of add them all up, you got to go integrate top to bottom, or bottom to top. Okay? It'll make more sense when I actually do problems. Okay, remember, if it's horizontal, I have to do an integral with respect to x, okay? Let's go to this next one. So find the volume of the solid formed by revolving the region given by these graphs. And we're revolving it about the x-axis. Is that horizontal or vertical? Horizontal. So my integral is with respect to what? Integrate by dx. Okay? So let's sketch those two. 8.11. So there's root x. Yeah. Here's f of x equals x squared. That's driving my math brain crazy. G of x equals x squared. How did I know? I graphed those. It's on my head. So the parent. I'm looking at, so if you remember back to pre-cal, I just remember the shape of the parent molecules. So like, you know how to do x squared, it's just a little u like that. And then the parent graph for square root is just like a little hump thing. Okay, so I want this little banana shaped region. Kind of looks like a banana. Or a plantain. Yo, plantains are fire.
They are.
I went to Central America one time, and we had plantain like every day. So we're gonna take this little region here, we're gonna revolve it around the horizontal axis. So we're gonna take it, rotate it in a circle, right? It's gonna form a little like weird hat shape. Weird cone shape. Okay, having trouble seeing that? Let's try the app. I got this app for 99 cents. It was 99 cents. Okay.
There's something.
Oh, it's like part of the program. Sweet, it's already in here. Look at that.
What is that?
This is. Oh, I know. Never mind.
Why is it like in layers?
Because. What?
I don't know how to do this. I feel like I missed it before. You know what I'm
So here's what's going on. We're taking this region, this graph here. I just don't understand. Okay, we're taking it, we're revolving it around the horizontal axis, so it makes this little like hat shaped thing. This is the shape it's going to make.
Oh, wait.
If you take this shape and move it around in a circle, this is the shape it traces out for you. It's like a little hat thing. See that? You don't see that? Okay, I appreciate the honesty. Okay, let's just do it formulaically. If you can't see it, just do, okay, here's how to think of it if you can't see it, okay? If we just want to get the right answer and move on with our life, okay? Here's how I want you to do it. What's my axis of rotation? Is it horizontal or vertical? So since it's horizontal, just do top minus bottom. Top squared minus bottom squared times pi. Times pi. Okay? So right here in my region, which function's on top?
Square root of x.
Square root of x is on top. So square root of x squared minus, what's the bottom one?
X squared.
X squared, squared, multiplied all by pi. Okay? We're taking an integral with respect to x, dx. Okay? What are my top and bottom numbers going to be? 0, okay? It's a bad habit to say 1, right? It's a bad habit just to go off like what it looks like. What's the best way to figure out what this x value is? Set them equal to each other. So root x equals x squared. Square both sides. X equals x to the fourth. 0 equals x to the fourth minus x. 0 equals x times x cubed minus 1. 0 equals x times, what is that? Same, opposite, same, opposite, always positive, x, 1, x squared, 1, x, okay? This can't be factored, so don't worry about it. So my two intersections are x equals 0 and x equals 1. Algebra 2 review, I know we all remember that. Just kidding. I forgot SOAP until this year, until I had to teach it again. But then I don't remember. Okay, sorry. It's going to go from 0 to 1. Questions, comments, concerns? Yeah, what's up? So my integral, I'm going to take an integral of this region from the left point where they intersect to the right point where they intersect. To figure out what those are, where two curves intersect, you set them equal to each other. How are we feeling? Right? Maybe you can't see it, but it's pretty formulaic. Top minus bottom, integrated from where they, top squared minus bottom squared times pi, integrated from where they intersect to where they intersect. Okay?
So red is top.
Top, yeah, red is the top. It's above the blue one.
So you do top and the bottom is
Horizontal. Yeah, but that also means you have integral with respect to x.
But then what if it's vertical?
Then you do right minus left, and you can integrate with respect to y. All right, let's do that integral real quick, okay? There's also the shell method, which we're not doing this year, but it's baller. Shell method. Pull the pi out. squared. That's going to be x minus x to the fourth dx. Pi times 1/2 x squared minus 1/5 x to the fifth. Evaluated from 0 to 1. Okay. Pi times 1/2 times 1 squared minus 1/5 times 1 to the fifth. Okay. Do you guys see how when I do subtract pi, and like, you see how this is going to be 0? You're seeing how that's just going to be 0 right here on the right. That? Yeah. Wait, we have the same water bottle? Okay, so just cross that out, it's just 0, goodbye. And then what do I have to do for the AP graders?
Exponent.
Just evaluate the exponents. What's 1 squared?
1.
What's 1 to the fifth? What? Funny. Some people struggle with 1 squared. Yeah. That's pretty funny. I never realized I'll find out what. Just like a Q student or something. Just a Q students doing like baseless things. Take my All right, there you go. They didn't have an example around the y-axis, which is kind of frustrating. All right, 12. 3 more example problems. 12. Okay. Volume with washer method revolving around other axes. All right, so set up All right, here we go. So what they're saying is, what's the region bounded by these 4 graphs? Do you see where do we see where that is? Okay. Little yellow guy right there, okay? And we're going to revolve it. We're going to revolve it around the line x equals -1. So we're going to revolve it around this pink dashed line. Okay, I know how to do this. I don't know how to explain it. So let me look at the notes. This is one of those that like. So what we're gonna do, we're gonna create a little like hook-shaped donut thing. We're gonna take this yellow region, and revolve it around the pink axis. So it's gonna make a little like ring. Okay. Okay, you guys want me to do that? Actually, it doesn't do vertical. My app doesn't do vertical axes. It's the worst 99 cents I've ever spent. Let us die young and we can live forever. Okay. Ooh, yeah, I could do a little transformation. Okay. So we're gonna take this, right? I don't know what the best way to do this is. Yeah, it's like a little like, thing. Yeah, it's like a bowl. There's no bottom. All right, so here's how you do this one. How do I want to explain this? What am I going to do? What am I going to go with? Got to make a game time decision here.
Vertical washer.
So we're going to do, so what's our, okay, there you go. That's a good way to do it. Right. So what is my axis? Is it vertical or horizontal? It's vertical. So I'm going to do right squared minus left squared, okay, times pi. Pi, and I'm going to integrate that with respect to which variable? dy. want this yellow region right here, okay? So here's what we're going to do. We're going to split it up into two integrals. Okay, so we're going to find, what we're going to do is we're going to find the volume of the surface formed when we rotate the green region around, and then the volume of the surface formed when we do the yellow region. Okay. So we've got to split it into two, okay? Let's do, so I'm going to color code these. Let's do the green volume. So it's going to be our final answer. So final answer. The final answer is going to be the green volume. So V1 plus the yellow volume. V2. Yeah, write that in mustard color. Okay. So let's do the green volume. So in the green region, and I've got to split this up. Here's why I've got to split this up. We'll see. Let's do the green region, okay? So it's going to be pi times the integral from, what do my y's go from in the green region? What's the bottom y in the green region?
0 to 1.
0 to 1. What's my right curve? What's the curve? What's the line? What's the graph of the line on the right? Yeah. So 1 minus -1. So 1 squared minus -1 squared, and that's an integral with respect to y. That one's not too bad. Not too bad, not too bad. That'll give me pi times 0 to 1. What is that? 0? No, that's not 0. That's 1 squared minus -1 squared. I can't. Oh, I'm sorry. That's the one on the left is that's x equals 0, right?
Yeah.
Sorry. Should be minus. The answer key says -1 for some reason. Oh, it says setup but do not solve. So that's the setup for the green region. So that's going to be part of our answer. So setup and do not solve. Let's do the yellow region then. Let's do the mustard region. Let's do the mustard region. Okay. So it's going to be pi times, what do my y's run from in the yellow region?
1 squared and x squared plus 1.
Bottom y value here is 1, the top is 2. And again, if we couldn't see that on the graph, how would we figure that out? Set them equal to each other. So we would do x squared equals, well, okay, we have to do it a little differently.
Wait, why do you have to pile?
That's just part of the formula. Yeah. So the area of the circle is pi r squared. So what you're doing here is you're doing two disk methods and subtracting one. That's it. So what's my right function here?
1.
1, right? It's okay, I'm just leaving my desk. just messed something up big. So what we're gonna do is we're gonna come back to this tomorrow so we can forget everything. And then we're gonna have a work day. Okay? Is that okay? You guys okay if we just spend the rest of the time working?
Yeah.
Thank you. Sorry about that. So yeah, we're good through 8:11. Sorry. So get that homework out and let's work on that, okay? I think we're gonna benefit more from that. I think we're gonna benefit more from that.